Another quick example. Here we're given that an integer b is divided by 6. So b is divided by 6. And then the result of that is divided by 2. So this is then divided by 2. The result of the division is increased by 8 divided by 4. So we add it to 8 divided by 4. And the sum is multiplied by 3. This would be our sum, and we're multiplying it by 3. We want to know the final answer in terms of the integer. So here I just wrote out what was happening as I went along in my problem to try and figure it out. But again, here we could use a backdoor technique. So if we want to maybe pick 12, because that's going to look good for divided by 6 and divided by 2, we could also do that and then figure out what this answer is going to be in terms of 12. So again, I'm going to do it the algebraic way really quickly, and then we can look at plugging in techniques. So here, b divided by 6 divided by 2 is essentially the same as b divided by 12. So basically I have b over 12 plus 2, all of this times 3. So this is going to end up giving me b over 4 plus 6, which I check over here, and that's one of my answers. It's D. So this would be my answer using the first technique. If I do it with plugging in a number for b, I should get the exact same thing. So here I have b, and I'm just going to set it equal to 12 arbitrarily so that when I divide it by 6, I get 2. And then when I divide that by 2, I'm just going to get 1. So equal to 1. And then I'm going to take the result of the division and increase it by 8 divided by 4, which we already did. So that was 3 plus 2, essentially. Or from here, we're taking this over. So 1 times 2. And we're multiplying that sum by 3. This is going to give us 3 times 3, or 9. So at this point, since we've plugged something in, we're then going to want to plug in the same number that we set for b into these different expressions, and whatever expression ends up equaling our same expression is going to be the one that's correct. In this case, we need to go through all of them just to make sure that we haven't used some weird number that could work for multiples, but this we should get the exact thing. So here, if we ended up plugging in 12 into here, we'd get 3 plus 2, which was not what we got down here. So no, here, if we put 1/2 times 12 plus 24, I'm going to get 6 plus 24, 30, also not my answer. Here, 6 times 12 plus 2. I could put that into my calculator, but I can definitely look at it and see that that's not going to be 9. It's going to be something a lot bigger, like 74. Here, if I put it in, I'm going to get 1/4 times 12, which is 3 plus 6, which is in fact 9, so that's 1. Or here, if I put in 12 plus 26, I'm going to get 38. So also not an answer, and either way I would have gotten answer D, which is my final answer. So again, you can solve these either way that you like, but the important idea is that if you can't figure it out, basically writing out an expression way or evaluating it yourself, these expression answers, which give you the variable in the answer, are great for plugging in techniques. Thanks again for watching Educator.com.